Modern photographers often argue about how the depth of field depends on the camera sensor size. This is indeed a very complicated and confusing topic that doesn't have a clear-cut answer. That's because there are multiple viewpoints and almost all of them are right in their own way. Let's clarify this with a visual example. Imagine that this circle is the image created by the lens. We will place sensor of different size under this circle, as if we are putting the same lens on different cameras. The largest sensor that could fit into our circle is the 6x6 medium format film. It's square, so it's look a bit unusual, but it captures a large area. Next, we will gradually reduce the sensor size. 44x33 is the modern digital medium format. It's significantly smaller than the film medium format, but still pretty large. The next format is 35mm. In the film era it was the most common, and now it's the format for advanced full-frame digital cameras. And finally, APS is widely used modern digital format in the affordable price range, also known as cropped frame. You can clearly see how the photo gradually loses a large amount of detail, which gets cut off on all sides by the frame boundaries. And eventually the small APS sensor captures only the boring center part. Now let's compare the largest frame 6x6 with the smallest one, APS, to understand where the depth of field is greater and where it's smaller. And here we encounter three different viewpoints that cause so much debate around this topic. Proponents of the first viewpoint argue that essentially nothing had changed and the depth of field in both shots is the same. After all, the lens remains the same, we just took and cut a piece out of the image circle. The second viewpoint is technical and forms the basis for calculation used in depth of field calculators. To comply with calculation rules, the right image needs to be stretched to match the size of the left one. The more we stretch the image, the less sharp it becomes. Compare these two parts of the frame, the right one is clearly more blurry. Along with the decrease in overall sharpness, the depth of field also decreases. That is, any decent calculator will confirm that the smaller the sensor, the shallower the depth of field, and the more the background gets blurred. This fact may seem quite strange, because we know how hard it is to blur the background, for example, when shooting with a tiny smartphone camera. Therefore, there is a third viewpoint that can confuse you even more. The third viewpoint is practical. In practice, there is no point in comparing these two frames because they turn out to be too different in terms of how close up the shot is. You can achieve the same closeness by putting a longer focal length lens on the camera with a large sensor. And we know that the greater the focal length of the lens, the shallower the depth of field. In the end, it turns out that the background will blur better on a large sensor. However, this blurring occurs not thanks to the sensor size, but thanks to the long focal length lens. This is an important note, but it's often ignored. And that is why misunderstandings and confusion usually happen. Now let's answer the question, can you beautifully blur the background while shooting in a small sensor? Yes, you can, because as we've seen, a small sensor by itself even blurs the background better than a large one, but you're unlikely to see all the beauty of this blur. Too little of it fits into the frame. A small sensor forces manufacturers to use shorter focal length lenses, and those are the ones that blur the background poorly. For example, on the iPhone SE smartphone camera, the lens focal length is only 4mm. Of course, it will be difficult to blur the background with such a lens, even when shooting at an aperture of 2.2. So, if you want to get a beautiful bokeh, it is still better to use a larger sensor, but don't forget about the other factors that also affect depth of field. And finally, if buying an expensive large format camera is not an option, there is a way to artificially increase the sensor size. You need to take several overlapping shots with the same settings and stack them together into the large panorama. If some today's terms were unclear, check out our educational videos on the channel, such as Photography Basics in 19 minutes or other great videos.